Welcome back. Over the past few videos, we've been building a VIT feature extractor and an FNet B2 feature extractor for our food vision mini problem. And now we want to gather some more statistics about them, or one final statistic, and that is how long each of them take to make a prediction on a single image. So what's our goal? Our goal model is 1, performs well. Both models do this, right? 95% plus test accuracy. And 2, we want is fast. I was going to say makes inference fast, but we'll just say fast. So 30 plus FPS if we can achieve it. And of course, back in the keynote, this is what we're doing. So we've built these two models. We know that they both perform well. Let's now build some code to test their speed. So you might have already given this a shot, but now let's do it together, hey? So the first thing we want to do to test the inference speed is let's go to test criteria 2. We want to 1, loop through test images. 2, time how long each model takes to make a prediction on the image. So nice and simple. How about we start off by getting a list of all the test image paths? So we could use a data loader for this, but let's make a function that we could just pass in a directory and loop over all the images in that directory and then make predictions on it with a given model and time all of those predictions. So that's what we want to work towards. So let's write down here. Let's work towards making a function called pred and store to do so. First, we'll need a list of test image paths. So we can do this by going from pathlib, import path, and just before we do, we've got a file path to the test directory. So here's our data, pizza, steak, sushi, 20% test. Let's now get all test data paths. We can go test data paths, we'll turn it into a list, hey? List, and then we'll go path. We'll use the path class to go test directory, and then we'll use the ever faithful glob to search through the test directory, so this file path here, and then star, so anything that comes after that. We've seen this a few times now. So test star, so anything in pizza, steak, or sushi, and then we also want to go another star here. So within the pizza directory, we want everything that's going to be ending with .jpg. And that of course is going to be the same across test pizza, test steak, or test sushi, every file path that ends in JPG. So let's see what these look like. Test data paths. Wonderful. So there's a bunch of file paths to all of our testing images, and we'll just cut this down for some space. We'll get the first 5. Nice. So what do we want to do now? Well, we want to 5.1, let's outline a function. We've said pred and store, but let's go creating a function to make predictions across the test data set. So what do we want this function to do? So let's just go step 1. Create a function that takes a list of paths and a trained PyTorch model, and potentially we want a series of transforms because we need to format each of the images of transforms. Might turn this into Markdown. There we go. And a list of target class names and a target device. So a few things to take in here, but essentially all we're going to be doing is looping over these images, making predictions, mapping those predictions to a class name, and then making those predictions on a given device. So we want to then start off by creating an empty list. Can return a full list of all predictions later. So we want this function to eventually return, let's go here, steps to create pred and store. We want this function to eventually return a list of let's make it a dictionary, one dictionary per prediction. Why do we want this? Well, you'll see later on that a list of dictionaries is one of the most usable data structures for inspecting different types of data. So we'll see that in practice. It's easier to see it in practice than talk about it. Then we want to go, number 3 is loop through the target input paths. And then the rest of the steps will take place inside the loop, except for the return step, of course. Number 4 is then we want to create an empty dictionary for each sample. So prediction statistics will go in here. This is what we're going to fill this dictionary by the end of the loop and then add the dictionary back to the list. So by the time we've looped over all of our test samples, we have one prediction dictionary per sample. Number 5 is we can get the sample path and ground truth class from the file path. So the ground truth label, of course, for each of these samples. For these images here, the ground truth label will be stake, and we want to be able to compare this to our model's prediction. 6, what do we have to do? We have to start the prediction timer. So we're going to open the image first, and once the image is open, then we can pass it to or start the timer and pass it to our model. So open the image, or maybe we start it before we open the image. Yeah, that's a good idea. We'll open the image using pil.image, so Python image library.image.open, and then we can just pass open in a path. So we'll have that path once we start looping through all of the test paths. So we pass that to pil image open. Then we want to transform the image to be usable with a given model. That's why at the start here, we pass in a list of transforms, so that when we're opening an image from file, we can pre-format that image or transform it to be capable of being used with our FNet, B2, or VIT feature extractor model. Step 9, what do we want to do for that? We want to prepare the model for inference by sending it to the target device. This would be important because if we're going to pass in a target device parameter, we want to make sure the model and the data sample are both on that device, whether it be CPU or GPU. And what else do we want to do? And turning on eval mode. Beautiful. Then what do we do for that? Well, I want to turn on torch inference mode because we're going to be performing inference, and inference mode is going to help us out by turning a bunch of model settings off that we don't need during inference. And then we're going to go and pass the target transformed image. So this is going to be from the image from step 8 to the model and perform forward pass. Then we want to also calculate pred prob plus pred class. So the raw logits, our model's raw output is going to be the logits. Then we want to go from logits to prediction probability. Then we want to go from prediction probability to prediction class. And then we can, once we have these details, we want to add the pred prob plus pred class to empty dictionary from step 4. That's when we can start to add some information to this dictionary here that we created. Step 12 is we want to end the prediction timer started in step 6 and add the time to the prediction dictionary. So once the prediction is done, we want to stop the timer, add how long it took to the dictionary, and then 13, we don't need to get these comparison metrics, but while we're here, we might as well get it anyway. So see if the predicted class matches the ground truth class. This will give us an indication of how many samples our model was wrong on. And then 14, what else do we want to do? Finally, we can append the updated prediction dictionary to the empty list of predictions we created in step 2. And then 15, of course, return the list of prediction dictionaries. Oh my goodness, a fair few steps here, but nothing that we can't handle. There's nothing here that's out of context that we haven't covered in some way, shape, or form throughout this entire course. We are at milestone project 3 after all. So I'm going to start this off, pred and store, and we want it to return from typing import dict, or do we want a list as well? So this is going to return a list of dictionaries. I think that's correct. Pass. Does that work? Wonderful. Okay, so my challenge to you is to go through these steps here. We've got our list of test data paths. We've got our trained models as well as their associated transforms. So if we come up here, we've got VIT and VIT transforms. We now also have a list of class names. And of course, we have a target device. So try and combine all of these things together, go through these steps, and we want to end up with a list of prediction dictionaries, one for each test sample. And we're going to go through this together in the next video. I'll see you there.